I'm going to be talking about hacking SQL Server on scale. This talk is really going to focus on weak and common configurations that red teamers and pen testers can kind of leverage to get unauthorized access to data naturally because it's a database, but also system access and leveraging it to, or the weak configurations for domain privilege escalation. I'm Scott Sutherland. I work for a company called NetSpy out of Minneapolis. I've done a few talks in the past, not here. This is normally a 60-minute presentation that I'm trying to jam into 25 minutes. So if I do cut this short, I will put the slides out. My Twitter's out there. I'll tweet out the slideshow link when I'm done. So this is what we'll cover. I'm going to be talking about kind of my general motivations for targeting SQL Server over other database platforms. Talk about a toolkit I released a couple months ago called PowerUpSQL. Briefly talk about how to locate database targets, and then I'll really be spending the majority of my time focusing on common privilege escalation scenarios that are useful for red teamers and pen testers. And if there's time, I'll lightly touch on post-exploitation activities and general recommendations for the blue team. So SQL Server is something we see in pretty much every environment we come into. I do app and NetPen work, and I see it on both sides of the house. It's also very tightly integrated with Active Directory and kind of the Windows ecosystem. And for that reason, it makes a better target than, say, Oracle or MySQL or things like that out of the gate because it has these trust relationships that just don't exist on those other platforms. PowerShell was nice because it's native to the platform that I'm attacking. And so I liked it for that reason the most. Also, I'm not really a programmer. I'm kind of a scripter. And so for me, it gives me flexibility, and I don't necessarily have to learn how to program right to get the job done, although I'm slowly trying to learn. So PowerUpSQL came about, PowerUpSQL, because I had a lot of onesie, twosie database scripts that I kept building and releasing. I got really sick of copying over code, and having to run them all independently against database targets. Also, I saw some stuff that Will Shorter did quite a while ago now, where he kind of went out and he looked at what people were doing in the industry, wrapped it all in PowerShell, made it very accessible, not just to pen testers, but also to admins. So now admins with limited knowledge of how this stuff works can actually evaluate their builds before they go gold or whatever. And I kind of wanted to bring that to the SQL platform. So general project goals were scalability. I started out with jobs, which really sucked, and they crashed a lot. So I leaned on run spaces from some data I found on blogs from Bo Prox and PS Rambling Cookie Monster guy. I also wanted all my little tool sets to work together, so I used the PowerShell pipeline, which will take information from one command and allow it to be very easily processed by another. And I wanted portability. SQL Server by default comes with these DLLs, these SMO libraries, and when you read the books on how to use PowerShell with SQL Server, they tell you to use these libraries, and I just didn't want to have to lug them around with me everywhere I went. So I leaned on the .NET framework and some older versions. I got some good advice from people in the community to kind of push towards 2.0 compliancy, so it could run on Windows 7 boxes and other things like that. Core functional goals were pretty intuitive. I wanted to find the SQL servers. I wanted to audit them, inventory them. I wanted to be able to do really basic vulnerability scanning and stuff. And I wanted to do that automatic escalation. There's a ton of functions that do other things in there right now. I wrote a wiki out on the GitHub. You can go check it out if you're interested. But it's like I said, it's a tight time slot, so I'm going to just kind of gloss over that and let you guys check it out independently. You can also download this from PowerShell Gallery if that's what you like. Okay.
If anybody wants to see it for a second.
Deck will be out afterwards as well. Sure. Sorry, my bad.
Helping them out.
There's also some basic install instructions here, and there's install instructions on the wiki that kind of speak to maybe the best way for your use case. So with that out of the way, let's just talk about SQL Server basics. For those of you who are not super familiar, SQL Server is just another application that runs on top of Windows. The core of it is a series of Windows services. So the important thing to realize about that is that anything that SQL Server does on the operating system executes under the context of the service account. And that's going to become important later, and we'll see why. Another thing to kind of be aware of are the actual user accounts. By default, Windows accounts are used. You can configure SQL Server to use native SQL Server configuration, SQL Server login accounts. But neither of those have access to data by default. They actually have to be mapped to a separate database user that exists in each database on SQL Server. So I have a little model up there for those who care. Also, there are two roles that you guys should be aware of that are important as we walk through this. The first is the sysadmin role, which is basically a DBA role, and a public role, which is kind of the equivalent to the everyone group in Windows, but for SQL Server. So we can't really attack what we can't find, so I outlined some basic techniques for finding SQL Server. Some are intuitive, some are less intuitive. We have the traditional techniques of TCP and UDP scanning of various types. But we do live in kind of like a cloud world today, so a lot of our clients are actually pushing their databases into the Azure cloud. And so what we found out while working with them is that when they register or set up an SQL Server database in Azure, it actually registers under this, databases.windows.net. And so you can actually use very traditional DNS dictionary attacks to enumerate potential database endpoints that are exposed to the internet. And Microsoft will come back and they will make a very legitimate statement, which is by default there's a firewall on that does not let people connect to those databases. But what we found through a little bit of research is that a lot of those are actually exposed to the internet. People are opening up their firewalls because they don't know where their traffic's coming from. And to amplify that, people are integrating their database code and their application code in GitHub, linking it all to Azure. And we found in many cases they're public repos. So you can go out to GitHub or Bitbucket or whatever. You can find not only the database database endpoints in Azure, but the connection strings that go with them. So if you're doing that, stop. Local database enumeration is pretty easy if you're already on a box. The one that's really interesting is domain user perspective. So if you've already obtained domain user rights for a dictionary attack or a phish or MBNS spoofing or whatever got you on the box, once you have that, you then have the right to actually query Active Directory for a ton of information. And when SQL Server is installed on a domain system, it actually registers itself along with the associated service account in Active Directory. And any domain user can query for all of the domain SQL servers because it needs to be there to support Kerberos authentication. So that's pretty powerful, along with many other attacks that could go with that. And then also Azure again. If you get the right domain account, you can just sign into the Azure portal online, or use the PowerShell modules to interact with them. So the idea here is that we used to have a surface of attack that was only internal, and the world put up firewalls and prevented people from directly accessing databases. And now people are starting to put that back out on the internet. So that's just something to be aware of. I wrote a bunch of functions, or 4 functions, to enumerate SQL servers from different perspectives. I'm going to do a demo in a sec, so I'm not going to go into those right now. But once you actually have a list of databases that you know about, typically what we'll do is we'll just try to gain access to them, test the current domain user's privileges. And there's a couple modules I made for that. The first will do dictionary attacks against all the identified SQL servers with either your current credentials or provided credentials. Actually, the get SQL connection threaded will use your current creds. I'll show a demo in a sec. I did do a command cheat sheet since I have a tendency to ramble in weird directions. I have the different user or attacker perspective on the side here, depending on what you're doing and where you're coming from, along with the associated commands. And once again, the commands do use the pipeline inspired by a lot of open source tools. So you can see here, like down at the bottom, we can do get SQL instance domain. If you run that alone as a domain user, you get the entire list of SQL servers, and you can directly pipe it into the second command, which will test your access to them. So it's a mini one-liner, which is nice. I'm just going to skip right into the demo. Okay, so first off, I'm just going to show you, this is us listing the local SQL Server instances. We get some service information. We get kind of state whether it's running or not. This is basically emulating you already owning a box. Now we're actually running as a domain user after we've imported the module naturally, and getting a list of SQL Server instances on the domain. And here we only have 9 because it's my tiny little punk-ass lab. But in a real environment, you have thousands of databases, thousands. I just did one last week with a mid-sized company, and there was like 3,000 instances in their domain. So it also gives you nice descriptive information. Along with that service account info, you can do really basic analytics with PowerShell and get a list of, how many service accounts how many servers are using each unique service account, so you can quickly identify potential attack surface for later on. Here's me actually actively running the command. It's getting the full list of SQL servers. I'm piping it into the thread connection test. It spits out, it tells us what we have access to, what we don't. It's pretty quick. But we don't want to have to rerun that discovery every time because that gets time consuming. So we can actually set that output to a variable and then reuse that variable moving forward. So in very large environments, the connection test might take like 5-10 minutes, and I don't want to have to do that every time. So now we can see after assigning it to a variable, I can maintain a list of my accessible servers, and then I can just pipe them into other PowerUpSQL commands. Now I got server information for all the servers. I have a list of databases on a ton of servers. So it makes it really, really easy to take consecutive actions or quick actions. So a lot of people will go through and say like that 3,000 system environment I just saw. We got access to 250 servers from a normal domain user perspective, and people are like, what in the fuck is happening? People are pulling out their hair and going nuts. We tried, over the last 6 years, we've tried to do some mild root cause analysis, and the short answer is admins give a lot of access that they shouldn't. They're on short timelines to get things into production, and they kind of rush and just get domain users everything. But the one that the reason people don't talk about as much is this privilege inheritance issue. So with SQL Server, when you install it on a box, Express specifically, the built-in users group has access to login. Not a big deal, especially if it's a standalone server. Nested in that users group is the NT authority authenticated users. Once again, if you're a standalone SQL server, no big deal. But the second you connect that box to the domain users group basically qualifies as an authenticated user. And now you've just given everyone on your domain the rights to log into your SQL server. So that's pretty insane, and that's one of the main reasons we see such widespread access in almost every environment we touch. So let's assume we have a lot of access now. We've logged in. We have some public role access as a domain user. We want to now get sysadmin privileges. There's a million ways to do this. I've just started scratching the surface, but so far, this sounds lame, but it's just weak passwords is still really common. That brute force script I showed you earlier actually leverages a technique for doing blind user enumeration. So if you run it as a domain user, it will connect. It will normally not have access to list all the users. It will enumerate them and then do some very quick dictionary attacks. But that same environment I just looked at, I think we found over 100 weak passwords in SQL Server that were just username as password. Nothing fancy. The other one is SQL injection into stored procedures. So stored procedures in SQL Server can run with elevated privileges via a few different methods. So if they're doing concatenation of variables and stuff, it's traditional SQL injection. You can run arbitrary code. Also, there's excessive privileges everywhere that we see very commonly misconfigured from a number of different perspectives. But on the whole, I didn't want to have to run these every single time. So as I mentioned, I created this invoke SQL audit script for those who don't actually want to do escalation. They just kind of want to list and create a vulnerability assessment report, basically. So we can see it run here against one of our instances. It will go through. Always use the verbose flag if you want to get feedback on what's going on. But you can see here it will output the affected computer, the vulnerability, if it's potentially vulnerable based on specific criteria, and then the command to actually exploit it if that's what you want to do. So that can be outputted naturally using PowerShell into a number of different formats. I also, like I said, I'm a red teamer and a pen tester, and I wanted that ability to press a button and become an admin, so I did. So here in this example, once again, we're doing access enumeration with the two functions we talked about before. We're getting a list of the systems we can touch, and we're going to use that server info function I showed you before to determine what systems we have sysadmin to. It's worth noting that out of the 250 systems we access in that other environment, half of them I had sysadmin on out of the gate. That's not uncommon. So here, we're just running the invoke SQL escalate privilege. It's running, and it looks very similar to the audit because it's literally wrapping it. And then at the end, it just does a check to see if we were successful, and you can validate that running the same command again. So it's a big time saver for escalation in SQL Server. It's useful during application assessments and NetPens. So now let's assume we've taken over, we're now a DBA, and now we want to impersonate the service account. Like I said, OS command execution means we can basically run as a service account implicitly. We don't have to dump a password, crack a hash, or pass a hash, or anything. Anything we run through SQL Server is going to run in that context. SQL Server can be configured with a lot of different service accounts, but because we have that SPN list, we know exactly what servers we want to touch that are actually going to give us the potential to escalate to a domain user. And it should be noted that most service accounts on clustered servers in enterprise environments have local administrative rights. So you're going to go from a normal user to, at a minimum in most cases, a local administrator on those systems, and then use your imagination from there. Another thing worth noting is historically people kind of lean on XP command shell to store procedure that executes OS commands natively in SQL Server, but there are like a billion other ways to do it to stay under the radar, because a lot of people will do auditing just on that function. You can import your own DLLs. You can use a bunch of different agent jobs. You can do registry auto runs through SQL native store procedures. So there's a lot of variability there. To take advantage of that, I wrote this tool, this additional function that can execute OS commands. So here we have our accessible list, which is that list of servers I know I can log into. And if I have sysadmin on them, when I run this, it's actually going to run whatever command I want in the context of the service account. And you can do that in scale. It's threaded and all that stuff. Also, shared accounts are really, really interesting. So we talked about basic service accounts, right? They run as, if you're a sysadmin, you can run OS commands. The OS command runs as a service account. But what I didn't mention earlier is that the service account inherently on every single version of SQL Server has sysadmin privileges. And on a standalone server, not a big deal. When you're in domain running hundreds or thousands of SQL servers using the exact same domain account, what that means is if you own one SQL server, you inherently have sysadmin privileges on all of those servers. And this is insanely common, and the answer I get from most clients is that it saves on licensing fees, I think. So go figure. So one account to rule them all. It's incredibly powerful lateral movement technique. We use it during SQL injection occasionally. I don't know if you can see the red, but come through, from the internet. You get to bypass the whole DMZ because you're landing in the database. And then we've hacked a lot of like marketing databases and things like that. Leverage the shared service account. We're dropping right into their bank database. So it's pretty powerful trust relationship. Like Gollum. So another really cool technique that's been around forever but is less known is something called crawling database links, or database link crawling. For those of you who are not familiar, a database link is basically a pre-configured set of credentials that's used by one SQL server to remotely pull data from another SQL server. So it's used for distributed queries and things like that, although it can do many other things, which I won't get into here. But the general idea is that link that's created is persistent, and the public role, any user in the public role can actually query data over that link. And when they do that, they're actually impersonating the user the link is configured with on the remote server. So if I'm on server A, I'm now running code on server B as that user. Which is cool. We can do XP command shell, all the other stuff. But what really compounds this is that we can crawl the links. We can nest them. And so we can crawl through environments pretty insanely. And here's an example of we do this via SQL injection quite a bit. So we'll come through, hit the database again, but this time we're not a sysadmin, so we don't have that command execution option. But we see a link on the server. It goes to DB1, still not a sysadmin. I'm sad. But DB1 has links to the banking database, and that is a sysadmin. So now I can crawl, through a number of different servers to get where I want to go. And this is insane because we've crawled these massive trees. They get us into business partners. They get us into PCI zones. They get us into high security zones because they poke a tiny little hole through so the databases can connect to each other. So it's a very powerful lateral movement method as well as escalation. So quick stats. We have about 50% of the environments we see this in. The max hops we have is we've hopped through 12 servers on a single crawl. Meaning 12 individual hops. And the reason it stopped is because the open query function I very briefly showed you has a character limit. So that is what it is. And then during that crawl, we hit 226 servers. Out of that, 225 we got sysadmin on. So just because of the link relationships. And there were thousands of links in that particular crawl. So we have actually produced code in 2012 and before that actually. A guy named Antti Rantasari and myself produced a bunch of those in the form of Metasploit modules. But Antti has taken it upon himself to rewrite them in PowerShell. And so I've included his script along with some other kind of auxiliary modules that will be wrapped into PowerUpSQL eventually in the Git repo for PowerUpSQL. So we'll do a quick demo of that because Antti's awesome. Couldn't be here, but at least you get to see his work. So right now it's a standalone script. You run it or import it just like anything. Kick it off. And it's going to go through and start with your first server, identify the links, identify who the link is configured as, and kind of track the path as it goes. So it's pretty intuitive, I guess. It's just like crawling links on a website, but, links in databases. I wish this went faster. It's not. Let's see. Okay, here we go. And anyways, it will finish. You'll get some summary data in hopefully a second. You kind of see the link paths get longer and longer. And then you can use that for remediation, hopefully, at the end. We were inspired by the Bloodhound Gang, and we started messing around with Neo4j to kind of visualize some of this stuff. And right now, this is just kind of a default view. It has no analytic capabilities. It's just like the most simplest visualization we could do without knowing what we're doing. So this is actually a live crawl I did 3 weeks ago that I anonymized the data. But this is a single server we got access to. And from that, this was the web. And then out of these, like half of these are sysadmin links. So it was pretty neat. I just thought I'd use that to help people visualize the impact. Now, this one's my favorite. This is another privilege escalation method. A lot of you guys are familiar. Who's not familiar with UNC Pass? Awesome. That makes this easy. All right. So UNC Pass, you know what they do. In SQL Server, there's a ton of stored procedures that support file paths. Everything that supports a file path supports a UNC path, just like pretty much every Windows thing ever. And so what you can do with those functions is force the SQL Server to authenticate to you, the attacker, as the service account. And from there, you can actually relay the password hashes out or crack them offline. So this is kind of what it looks like from an attacker perspective. You would connect to whatever, server one. You'd force it to authenticate you. In most cases, you're going to target two servers that are running the same service account because you know they have privileges on each other. You know you have local admin on that box. You don't have to guess. You don't have to spray. So you'll relay it over. You'll get checked out on authentication, and then you can push your payload over, whatever you want to do. And, right? So the reason this is so impactful is that the public role, that means everyone who can connect to SQL Server regardless of privilege, by default on every version of SQL Server ever has the privileges to execute XP directory and file exists, which you can put UNC pass in, which will then force the server to authenticate to you, where you can capture their hashes. So that's cool. I reached out to Microsoft a while ago, and they basically said it was intended use case, so it is what it is. I wrote a kind of ad hoc script, once again, that I'll plan on rolling into PowerUpSQL eventually. And it does everything I just described. So you load it up. It actually uses, so you import PowerUpSQL, and then you import Envoy, which is this amazing toolkit. It's kind of like Responder for PowerShell, written by this guy named Kevin Robinson. Sorry if I fucked up your name. And then you'll run this script. The script will do the SPN dump. It will take that. It will attempt to connect to all the SQL servers, and then it will do that UNC injection and capture all the hashes with Envoy, all via PowerShell magic. So this is my small environment of 9 servers, and in about 3 seconds, it starts to rain hashes. So now you're just seeing service account hashes come through, and this might seem like a lot, but it's very little. Like, for example, 250 servers, we would have been getting 250 servers worth of hashes coming through my screen there. So it's an incredible way to do privilege escalation. Naturally, there's some implicit lateral movement there. So I think I have like 2 minutes left, so I'm going to rush through this. You can go from basic OS to sysadmin. There's a lot of ways to do it. If you're OS admin, you can dump the LSA secrets, and older versions, you can just get it. You can do process migration, token stealing, single user mode. Pick your poison. Here's a slide with a bunch of tools. Download it offline. Play with it. It's very easy. Gets you data from an admin perspective that you wouldn't normally have or weren't intended to have. Post-exploitation, I know I'm going through this super quick. We have establishing persistence, finding sensitive data, and exfiltrating that data. Persistence is really cool in SQL Server because you can actually maintain access and execute OS commands and store all your periodic execution, whatever your persistence method is, on the SQL layer. So you never have to drop anything in the registry. You never have to drop anything on the disk. It's stored as an SQL object and then executed based on whatever the trigger is. So there are literal triggers, just like in Windows. In SQL Server, you can configure. There's agent jobs, which are very similar to scheduled tasks. You can mod and backdoor existing functionality, or you can use startup procedures, which is very similar to kind of the current version run in Windows registry. So all of this stuff is on the SQL layer, never touches the OS. And then naturally, anything you can do on the OS, you can do through SQL Server because you can just push that down. Couple tips for finding sensitive data on scale. Look for large databases. Look for databases using transparent encryption. Transparent encryption is exactly what it sounds like. If I log in as a sysadmin, I can see all the data. It's only good when you pull the disk out of the drive and walk out of the building. So a lot of people are using it for PCI compliance and other types of compliance, which means if you hit it logically, you're going to get everything. So it's very good for targeting. That was I think that's James recommended that to us, which was awesome. Also searching by keywords. It's Digit Ninja. I think he's the first person I saw use this technique. It was like 2 decades ago or something. But anyways, give credit where credit's due. And then data exfiltration over 1 million different avenues. Everybody familiar with exfiltration techniques generally? TCP, UDP, direct database connections, etc. Yeah. All right. Let's jump to the data dumping. There's a bunch of cheat sheets for you guys there. Check it out offline since we have like 30 seconds left. I wonder if this is actually going to play. It says it's going. I'm in deep thought. Anyways, I'm grabbing, in theory, the list of SPNs and I'm piping it right into the threaded data. So you're basically going to be, you could run this against your targeted list as well. I don't know why this, oh, there we go. Okay, right. So you could pipe your whole list of accessible servers to this. It will scour all of them for specific columns containing keywords. And if you're looking for cardholder data, I also have a LUN formula check, so it will check that. So that's really, really nice. We find tons of cardholder data outside of PCI environments using that, so that's handy. Anyways, general recommendations. Enforce the privilege of least privilege everywhere. Disable all those dangerous store procedures we talked about that result in public basically directly owning the server out of the box. Audit and fix insecure configurations on a periodic basis because the surface of attack and known attacks will change over time. A ton of people do application pen testing. Very few people do database pen testing or database configuration reviews. So make sure to include that in your planning, in your attack security development life cycle. You can also use policy-based management to standardize and enforce your configurations on SQL Server, and make sure to enable auditing at the server and database level. Everything that I talked about today can be audited. There's an event ID for all of it. And I've done some blogs, so if you want the details, go check those out. Otherwise, any questions? I know that was too much information in a short amount of time.
God, sorry. Wow, you blew my mind. Let me try to go back all the way back to the beginning.
30 seconds ago. Okay.
There was a vulnerability where a SQL Server was built offline and added to the domain, and that's where domain users get invited. Is that the vulnerability? Is it when you build a SQL Server out of the domain and then add it?
Now, let me clarify. It could be built while attached to the domain or built prior to being on the domain and then added. As long as it's on the domain, it's vulnerable. Sir?
Can you publish all the gist of like all the demos you did?
The question was, can I publish the gist of all the demos I did? I don't know how to do that, but I will work with you offline to publish the videos as gist. All right, I got time. Thank you guys for everything and attending. Have a good time at Derby.